To solve this linear system by substitution, I could just substitute the value 2x minus 3 for y in the first equation and go at it. But I noticed something interesting, curious here, that 7 divides into every one of the coefficients in this equation. So if I divide both sides of that equation by 7, I end up getting 2x, 7 goes into 14x 2x times, and minus, the 7's cancel, leaving minus y there, and 7 divides into 21 3 times. Now that looks a lot like this other equation, this strange similarity. And if I solve for, well, let's just substitute and see. We can substitute. We can substitute this value of y into the y position of the first equation, into that variable, and we end up with 2x minus y, but y is 2x minus 3 now, and this must equal 3. So distributing the negative through the parentheses here, we end up with 2x, negative 2x plus 3 equals 3. Because a negative 2x is negative 2x, and a negative times a negative 3 is a positive 3. And notice that the x's cancel each other out. 2x minus 2x is 0. So our equation becomes 3 equals 3, which is always true. A tautology. What this means for us is that these are two equations of the same line. Instead of two lines, it's really just one line. It's the same line. This means the system is dependent. And that's the answer to this problem. We'd say that this linear system is dependent. And that in turn means there are infinitely many solutions. They're both the same line, so they intersect each other everywhere. The same line. Infinitely many solutions because every point on that line is a solution.